Hello everyone and welcome back to my channel. So today we're talking about a very important topic for grade 12s. It's called transformations. Now, when you guys first learn about this, the most important factor is probably going to be the formula. So as we know it here, we have y is equal to af of bracket b bracket x minus c close brackets plus d. In some schools, they replace c and d with h and k, but they have the same functionality. Okay, so let's take a look at what each component does, and we'll explain afterwards. So first of all, let's take a look at it from left to right, as we normally would for any mathematical formula. A here represents the vertical stretch and reflection. Now, in some schools, they might be using the words compression or expansion, so be aware of how you have to adjust depending on how the wording goes. B here is going to be your horizontal stretch and reflection factor. C is going to be your horizontal translation, also known as a horizontal shift. And D is going to be your vertical translation or vertical shift. All right. Now, the order of transformations is important because if you do them in the wrong order, then you'll get a totally different graph, potentially the wrong graph. So you have to make sure you follow these rules. So step number one, you can always do stretches and reflections first. It doesn't matter which one, as they're seen at the same level. And then lastly, you would then do your translation or your shifts. Okay, so always remember to do your translations and shifts last. All right. Now we're going to take a look at a common example that is given to students, and this question tends to cause a lot of errors. So let's take a look at why. So it says, for example, we're going to list all the transformations where the original graph was supposed to be y is equal to f of x versus this transformed version. Now, the first step that you have to do is make sure that your b value gets factored out from the connection to x. So for this one here, if you look inside the brackets, we have 2x plus 10. You do need to make sure to factor out the 2 first. Now the reason why we do that is because, as you can see here, if we factor out the 2, then what's left is x plus 5. That plus 5 becomes the actual horizontal shift. A lot of students do get the b value correct because it's always 2, but a lot of students assume that 10 would have been the shift versus 5 being the shift, and therefore if you have that difference, you would get a totally different graph. So for this one here, let's take a look. So if we go back to our previous explanation of each component, we'll see here that A has a value of 3, and that represents a vertical stretch by 3. The B value here is 2, which tells us it's a horizontal stretch by 1/2. So anything with relation to horizontal is normally the opposite of what you see, all right? In this scenario, B, if it's 2, you do the reciprocal, so that's how we get by 1/2. For C, you see it's again connected towards X or the horizontal material, so though it's plus 5, we do the opposite. In this case, it would be minus 5, which tells us that we should be going 5 to the left. Now, anything dealing with the verticals, it is exactly as you see it. So in this case, D was a vertical shift, which means up or down. In this case, if it's minus 7, that just means 7 down. Now, a lot of times, once you've figured out your A, B, C, D, your teacher would want you to graph what does your transformation look like. So rather than graphing like each part one by one, so some teachers will have you graph like A, and then B, and then C, and then D. So potentially you'll have like 4 graphs until you get to your final version. That's a lot of drawing and takes up a lot of time. So what I recommend is something called mapping. So let me explain what mapping is. So what mapping does is we take the original coordinates. So for example, you do a table of values and you have 5 points. Okay, I'm going to take those original 5 points and I'm going to apply all the transformations onto those 5 points to where their final positions would be. So let's again take a look at our example. So again, we have our A, B, C, D, as we've mentioned before, but now we can turn them into algebraic equivalencies. For example, A here was equal to 3, and that meant a vertical stretch by 3. So normally that means your y value gets tripled, and that's why we have it equaling to 3y. The b is equaling to 2, that again was the horizontal stretch by 1/2. So in this case, that means your x values get halved, hence 1 over 2 times x. The c value was equal to -5, so again that was 5 left, which means your x values would be 5 to the left, meaning x minus 5. And then lastly here, d was -7, which meant 7 down, which means normally if you're at y, you're now y minus 7. Now putting all this together, let's take a look. How do we get to that final bracket? So if I put b and c together, right, b and c is all about the horizontal stuff, everything relating to x. And we said, first of all, we have to do stretches first and then shifts and translations last. So that's how we get the 1 over 2x minus 5. And then if you do A and D, those are your vertical materials. So again, we do stretches first and then translations last. And that's how we get 3y minus 7. So now that you have an algebraic equivalency, you just take your original 5 points, apply those with the algebraic transformations, and you get their new points. Those new points are now being mapped to their final location. Then you can just plot those 5 points and then draw your graph as needed, and then you're done. So that pretty much does it for today's short lesson. I hope you've learned a lot today. If you learned something and you feel like this is worth sharing, please like and subscribe and share the video with all your family and friends. Thank you for listening. We'll see you in the next one.